not we remember it or not. We have studied arithmetic and geometric sequences, and we have talked about series. So series is just where we add them up, correct? So arithmetic is where we have a common difference. And because that common difference is constant, if we graph it, it appears to be linear. And because it's linear, we can tie that back into slope. Okay? Our formula looks like this. To find the nth term, you take the first term plus n minus 1 times d. That should ring a bell. When we did it, we called it a sub n equals a sub 1 plus n minus 1 times d. But then when I gave you the test, I put it all in terms of t, because that's normally what we see. The nth term is the first term plus n minus 1 times d. But if it's arithmetic, sometimes they use the a instead of the t. All right, so an arithmetic sequence would just have a common difference. So if we had something like this, 2, 5, 8, 11, dot, dot, dot. That is arithmetic. Okay, what is my common difference? 3. Okay, so in this case, D is 3. So if I ask you to find, which they could on the ACT, SAT, the 100th term. Okay? So if I ask to find the 100th term, it's the first term plus 100 minus 1 times 3. So it's 297 plus 2, which is 299. Okay? So do y'all remember doing that?
Yes.
And we did lots of versions of that. So I might tell you that the 15th term is this, and the common difference is this. Find the first term. So where we take this and we plug in various things and we solve for what's missing. Okay, the other thing I could do is I could tell you that the 24th term is 52, and the 29th term is 62. What is the common difference? Okay, because this ties back to a linear, all you really have to do is think of this as the slope between these 2 points, and that would give you the common difference, right? So we could do the 62 minus the 52 over the 29 minus the 24, and that would be 10 over 5, so the common difference would be 2.
That's right.
Okay? So, we presented these a lot of different ways when we studied this in Accelerated 2, whatever the second course was called. Yes, sir.
This is a really quick question. I don't want to think about it because I had it before. But for the AP exams, you know how we're not, like, you don't have to come to school or whatever? I want to exempt this class off attendance, but I can't miss another day. Would that count as, like...
No, that doesn't count as an occurrence. No. It just says testing all day long. So it does not count as an occurrence. Okay. So any questions about arithmetic sequences? All right. Then we talked about little Freddie, if you had me. Oh, no. Frederick Carl Gauss. And we talked about how when he was a youngster, he was annoying to his teacher because he finished everything early and then he misbehaved. And so the teacher one day sent him back to his desk and said, add up all the numbers 1 to 1,000. And she thought, well, the teacher was a male, thought it would take him a while to do that. And he came back about 30 seconds later and he had it.
Is this a real story?
Yeah. Yeah, it is. It's said it's a real story, but it's been a couple hundred years.
Somebody
so,
told
yeah,
me.
you know. All right. So what he did was he figured out a way to do it. Okay. So I'm not doing. I won't do 1 to 1,000, but let's do like 1 to 10. 4, 5, 6, 7, 8, 9, 10. So what he did was he lined them up that way. Then he lined them up this way. And he noticed that if you do that, what are all the sums? 11. How many 11s do we get? 10 of them. We get 10 11s. But instead of just adding up 1 to 10, I added up 1 to 10 plus 10 to 1. So I added it twice, so he divided it by 2.
So it's 10 divided by 100.
And so he figured out the formula. The number of terms divided by 2, the first one plus the last one.
How old was he?
Elementary, so at most 3rd grade, they said. According to the story.
I went
But elementary
Alright.
was a lot higher there, wasn't it? Like you were older.
dividing by 2.
Alright, so that's how little Freddie developed the formula, but this is our formula. So to find the sum of a finite number of terms, S of n, you would take n divided by 2, the first plus the last. This is on the SAT. And so if you were trying to find an arithmetic sum, all you need is the first term, the last term, and then divided by 2, and that would give you the sum. So let's say we took this same one right here, and we wanted to find the sum of the first 300 terms.
Wow.
It would be 300 divided by 2. The first term is 2. How do I find the 300th term?
Use the explicit formula.
Yeah, go back to the explicit formula. So the 300, we would just plug in 2 plus 300 minus 1 times the common difference. So this would be 897 plus 2 is 899. And then we do 150 times 901. And that's 135,150.
Oh my lord.
That's what I
Okay.
was thinking.
So that was when we used arithmetic sequences using the explicit formula and finding the sum of a finite number of terms. Alright, so with arithmetic, there's a common difference. You can find it by taking any term, subtracting the prior term, and that would give you the common difference. With geometric, there's a common ratio. So generally what we say here is with arithmetic, we're adding the same thing every time. And with geometric, we are multiplying by the same thing every time. Now, when we have repeated multiplication, isn't repeated multiplication a shortcut to writing that just to power? And that's why we have this formula. We wrote g sub n equals g sub 1 times r to the n minus 1. But this stands for our first term in a geometric sequence. R is the common ratio, and n is the number of terms. So if I started off at 128, and then I had 64, and then I had 32, and then I had dot, dot, dot. That is geometric. And my common ratio is 1/2. Do you see it? Yeah. Okay? If you take any term and divide it by the term before it, 64 divided by 128 reduces to 1/2. 32 divided by 64 reduces to 1/2. So my common ratio is 1/2. Alright? Now, I also see the first term, so I can come up with this explicit formula specific to this example. The explicit formula would be T sub n equals the first term, which is 128, times the common ratio, 1/2, to the n minus 1. So if I ask you to find the 13th term, you would just plug in 13. So you do 128 times 0.5 raised to the 12th. Okay? And that gives us 0.03125. If you're taking the SAT, ACT, they would change that into a fraction more than likely, 1/32. Okay, so that is geometric. That is using the explicit formula. All right, now, if we were to find the sum of the first n terms, so a finite number of terms, so the sum of the first 12, the sum of the first 8, the sum of the first 1,000, okay, we would use this formula. Now, when you put this in your calculator, guys, this ratio if it's negative, needs to be in parentheses here. Okay, so if the ratio happens to be negative, which it could have been here, if I made that negative, this would have been negative, right? And I'm raising a negative to an even power, so it would become positive. So the ratio can be positive or negative. And if it's negative, make sure this goes in parentheses. If you're putting it all in at once, the denominator needs to be put in parentheses. Otherwise, you're telling your calculator to divide that product by 1.
We have 6 seconds. The time starts.
All right,
Play a game.
jump up there. You got this. You can do this.
Spider-Man.
We're not sure. I just ran
I
them.
really want to just.
No,
Let's
on.
just look off one room.
Everyone jump at once, shake the.
I really just want to jump in town.
All right, that was good.
Did you cut the red wire?
Yes.
All right, nice.
No one helped. Spider-Man got
Push him.
Okay, so if I wanted to find the sum of the first 13 terms, okay, the first term is 128. Let's go with my ratio being negative, since I just changed it. So we do negative 1/2 to the 13th, divided by 1 minus negative 1/2. Okay? And let's all punch that in together and let's see if you're efficient with your calculator. Not efficient, proficient.
Where can you buy calculators?
just normal batteries.
Oh, yeah.
I don't think they have specific batteries.
You know, if you open up a AAA, you just get a bunch of those small batteries.
Well,
You open up a AAA battery, you just get like 5 really small batteries that you just can use for like a watch. Maybe not watch, but like laser
You
pointers.
open them? I thought it was like.
Wrap around.
hang well.
It's like an aluminum cover. I've never eaten a battery though. I haven't tried that yet.
You should have typing
I'm thinking about doing one of those small watch batteries.
Edward, I'm recording.
insert quote here.
See, I gotta know when she's recording.
I'm very obvious. Like you see the screen.
Oh, there's just notes.
Just one battery.
Yep. Okay, did you get what I got?
Yes.
I would have.
You would have?
I need batteries.
Okay, now this last one, the sum of an infinite number of terms. We can't always do it. Because when we think about this being exponential, right? Because it's raised to an exponent, it's exponential. And when we graph an exponential, a couple things can happen. If we graph the exponential this way, all right, as n gets infinitely larger, can we capture this?
No,
No.
it's the other way. When it gets
It's the
smaller,
other way.
Eventually, you're adding such a small amount, it's not effective.
Right.
What? Good job.
Okay.
What?
So going this way, as it approaches 0, we can do that. Okay. And then, if it's negative, a couple things can happen. If the ratio is negative, it's going to bounce. It's going to go back and forth. We have one that goes this way.
Hey, that makes a.
All right, and this diverges.
It splits.
It splits. And when it's divergent, we cannot find an infinite sum. But if it converges,
Big and small.
Wait, if it diverges, when they kind of cancel out though?
as we approach infinity, what does this approach?
Zero.
Now it keeps flipping which side it's going to be on. Okay, so hopefully you remember that we can only find this if r is between -1 and +1. You can only find the sum of an infinite number of terms if your common ratio is between -1 and
Can it
+1.
be -1 or +1? Like, is it greater than and equal to?
Okay, what would -1 and +1 be?
0, which is undefined.
Obviously.
Colin. Come on.
Come on. Cavs fan.
Well, the -1 would be 2, but the 1 would be 2.
1 minus -1.
He says these are broken.
Yeah, it's 2.
I'm a big man.
It is not undefined.
Oh, yeah,
R
sorry.
raised to 0 is 1.
Never trust a Cavs fan.
We'll look at those in a second.
These rows.
Alright, so number of terms, if this is our sequence, so it's 128, and it would be 1 minus r, which we changed to negative 1/2 just a moment ago. So it would be 128 divided by 1.5. And that is 80.
5.8.
Wait,
Same thing. What the heck?
hold on, hold on.
It's the same thing.
Oh, whoa.
How is your number bigger than the smaller than?
You tell me.
Because,
What was your question? I was way too late.
I was smaller.
Wouldn't it be like a little bit bigger, but not much bigger?
Yeah, something.
Okay, what would happen is when I did this negative to an odd power, it's negative, and minus and negative make this positive. Divided by the positive, we've left out that counter negative on it. It didn't balance it out. So that's why it's slightly larger. That's unique. I like that. Okay. So that is what we had previously studied about arithmetic and geometric sequences and series. Okay, new part. Our notation. Okay? Now, this we know means sum. We've talked about that before. Capital sigma means sum, to add up. Now, when it's in sigma notation, the number down here tells us where we're starting. So we're starting with the first term, we're ending with the
Last
fifth.
fifth.
That's what that means. And then how would we find those terms? We could just plug it in. And so let's do that, and then I'm going to show you how that ties into, if I wanted to use the shortcut formula, what I would do. All right, so if I plug in 1, I get 2 times 3, and 2 times 3 is 6. Okay, if I plug in 2, I get 2 times 9. 18. If I plug in 3, I get 2 times 27.
49.
Also known as 54. If I plug in 4, I get 2 times 81. 162. If I plug in 5, I get 2 times 243.
486.
Okay, and then I could add those up. But, can you tell that this is geometric? I can tell from here it's geometric because repeated multiplication can be written as a power, right?
Oh, yeah.
So this is my R, but this is not my first term because it's not to the n minus 1, it's just to the n. This is my first term. So I certainly could use the formula to add those up, right? So the sum of the first n terms, because we know it's geometric, and in this case my n is 5, would be the first term, which is 6, times 1 minus r. What is r? 3 to the n, 5, over 1 minus r. All right, gentlemen, use the formula. Ladies, add it up. Julian.
I'm using a calculator on my phone, so I think I'm
Okay.
Ben, you're not gender mutual, so hush.
What app is that? It looks pretty cool.
Wabbit EU. It's actually Wabbit.
Is that an Android
Yeah.
phone? Yeah, they
It
don't
looks like a
have
really
it.
nice app, honestly. It looks like.
Yeah, I mean it's awesome.
So you're
But I can't get it because I have an Apple.
Wait, I kind of want to download it because I've had so many times where I didn't have my calculator on me.
Yeah, right.
I downloaded the Desmos app and I use that.
But you can't like do. Can you do multiplication on that though? Like 5
Yeah.
times 6.
It has both a graphic and scientific.
Are you posting this video?
About battery eating?
No, he's like actually at the witch's office.
Probably.
I usually try to stay quiet whenever I do your
Alright, so did you do it for real?
Yeah.
Okay, you add 726? Alright, do all the gentlemen agree with 726?
What?
Alright, ladies, what'd you get? 726. Alright, we got the same thing, so we're good. Alright, so that is it for our review, and now I have practice for you. Now this practice is due Friday. It's due Friday because I may or may not see you tomorrow. Depends on when testing gets over.
All right,
Okay.
for 2 weeks.
So and
The review's due Thursday.
the test and review are due on Thursday.
Oh, the review wasn't due today?
Oh, that
All this stress for no reason.